Well, hello everyone, and welcome to today's webinar on the HighByte Intelligence Hub, where we're going to discuss and demonstrate some of the newest capabilities from last week's release. My name is Tony Paine, CEO of HighByte, and with me is my fellow co-panelist, John Harrington, HighByte's Chief Business Officer. We'll be recording this webinar, and we'll share a link with attendees in tomorrow's follow-up email. With that, I'm going to shut off my video now so it doesn't interfere with the slides and demo. So for the agenda today, we're going to cover the HighByte Intelligence Hub value proposition and talk through some of the new improvements available in last week's 1.1 release. Next, we're going to jump in and demo the new features. And lastly, and perhaps most important for the HighByte team, is your participation. If you can submit any questions via the Zoom webinar tools, we would greatly appreciate learning what questions you have to ask and what you would like to know about HighByte and the Intelligence Hub. You can do this throughout the presentation at any point in time. And at the end of the demo, John and I will answer as many questions as we can before the webinar concludes. We also hope that you will remain engaged with HighByte, helping us to drive the direction of our company and products, as well as test drive this newest version of the HighByte Intelligence Hub. Manufacturing companies, as you know, are digitally transforming. They're layering new Industry 4.0 technologies, such as industrial IoT dashboards, analytics, machine learning, and many of the other types of applications shown here on top of existing infrastructure. These new technologies require access to operational data, pushing companies to extend factory floor operations outside of the typical operational networks through business IT networks and into the cloud. These new technologies are not just connected to a single site. They connect across all manufacturing sites, giving the business a holistic view into the entire operations. The challenge is that these sites were installed at different points in time. They were engineered by different teams, each with a mix of varying equipment and application software, each using geo-specific units and introducing localization differences. The list goes on, but in short, everything looks different. So how can a holistic view be achieved? Well, this is the promise of the HighByte Intelligence Hub. Unlocking the value of industrial data for any application, new or old. Though the entire enterprise is going to benefit from this value, the product was designed to be used, configured, and deployed, but by those who understand operational data best, the operations team. The product allows an organization to abstract away the creation and maintainability of information models, the blueprints, or what I would say is the standardization of how an asset, a process, a system, really anything is represented across all sites. These models can then be wired up to real-time data collected via industry standard interfaces, as well as inject metadata that provides configuration data or asset data, such as units of measure, valid operating range, or any other type of information that provides clarity around the meaning of the data and the associated model. The HighByte Intelligence Hub is a codeless environment, meaning you do not need to be a software architect or developer to design and implement the models that represent your environment. The product runs on premise, host to operational equipment and devices in order to be able to handle the unique operational requirements and securely publish data to the cloud at either a specific frequency or under a set of certain conditions. In addition, you can easily manage the various flows of information. This is the pipe between the raw data collection and the publishing of standardized and correlated information. In this way, you can turn off the flow of information from a central location in the event that it is no longer to be made available to a particular application or user. And lastly, the Intelligence Hub was designed for changing environments. The user has the flexibility to create new models or extend existing ones without requiring a restart of the system. This simplifies the ongoing maintainability to a single layer in your digital transformation technology stack. So what's new in version 1.1? Well, as you'll see soon, we've done a major rehaul of the configuration component, making the user experience not only more intuitive, but more performant and easier to work with larger data sets. We've added support for inline editing, along with the support for bulk operations to cut down on the number of clicks to get your configuration task done. If you have pre-existing connections, models, or flows that's close to something that you want to reuse, you can easily replicate these through cloning and then just change the few parameters rather than having to start from scratch. We've also added inline documentation, the ability to describe your work so that you or someone else can reference it later and understand what was done. When creating a model, you no longer are restricted to assigning attributes with primitive types like strings, booleans, integer, or real values. An attribute can now be assigned to any model that you define within the hub, allowing you to construct complex, sophisticated models made up of reusable parts. Whether you like to start at the plant and model down, or start at the sensor level and model up, the user experience will not force you into any specific design pattern. And the last highlights are around information flows. Previously, information flows executed at a user-defined interval. In this release, flows can now be set to execute based on one or more conditions. For example, if a particular device's health status changes, an alarm is raised, or while a batch is in progress. In addition, if a flow executes and the end result is the same as the last execution cycle, you can now select whether or not to publish the unchanged piece of data or all pieces of data. So with that, enough talking. Let's jump in and see some of the new HighByte Intelligence Hub features in action. So we've removed some of the busyness from the login page. You know, the quick start and other useful support information is still accessible, but in the background, because at the end of the day, the whole purpose here is actually to log in and start configuring your project. Some of the things that we did was around usability and help the user guide them through project configuration. So if I was to go and create a new connection now, and basically, you know, forget to actually put in a particular parameter that's required, we are actually going to point you in the right direction and tell you what settings are required to be able to go and configure something properly. I'm just going to put something in here. The other thing we do is we actually tell you what the range value was. Prior to that, we actually would try to fix it on your behalf without really alerting the user. So now you get a full understanding of what we expect for settings without having to grab the product manual. The other thing we did was we provided inline editing capabilities. So if you have existing configuration elements, you don't have to pop up another form-based dialog to actually go and manipulate an object. You can do it inline. We also provide you keys as to what you're actually doing so you could revert them. So if we basically type in, this is a description, I know that they basically have actually modified this field. Likewise, if I go and change the port, I can see this is edited so I can review all my changes before either committing them or undoing them through a reset. The next user improvement is around OPC browsing. We're going to actually go and browse to a particular data server. And what we've done is, instead of having a tree that continues to build outwards to the right, we actually have flattened it and allow you to basically see the actual path of where you are. So for instance, if I go into the plant, I look at my asset management system, the particular machine that we're going to actually work with as part of this demo, I can select some tags. These will now show up here so that you actually can get good visibility on what is actually going to be imported to the project if you choose to continue. Though you can go back up a level in the branch, you can also click any point in the actual browse tree to jump around. So in this case, I know I want to go get operational data for the same machine. So I'm going to go back to the plant. I'm going to go to the line and then look at the machine operating characteristics and pull those into the project as well. Again, I can go here, and if I added something that I do not want, I can basically delete the category or individual items before importing them into the hub. At this point, we've actually gone and connected to a particular OPC UA server, browsed some information, and pulled these data points in so that we can actually do something useful with them when we actually model. So let's get into modeling. One of the biggest enhancements we added this time was the ability to go and create nested models, allowing you to create complex representations of real world things. And so what we're going to do today is we're actually going to create a machine model, something that models a particular machine in my environment. I'm going to create a model. I'm going to give it a machine name called machine. And now I'm going to go and basically define what that blueprint of a machine should look like. And those are through attributes, if you're familiar with the product. The first thing we're going to do is we want all type of devices that we model to contain asset information. And so I'm going to basically add a new attribute called asset information. And I'm going to take advantage of a particular model that I've already created in the product that models what asset information should look like for any device. I can actually look at this inline to see what asset information will hold. It'll hold an ID, a serial number, and a purchase date. Pretty trivial for this example, but it shows that you can actually view things inline without actually having to step back and look at these separate models independently. The next thing we're going to do is we're going to basically give a few more attributes to this machine. We're going to do a couple primitive attributes, and then we're actually going to build a model inline. So the first thing I want to do is I want all machines to expose an online status. It'll either be on or off. So this will be a Boolean. The next thing will be an attribute that'll actually show the utilization of the machine. And this is going to be basically a percent, work in process utilization. So I'm going to pick a floating point value to represent this particular attribute. And then lastly, what I want to do is I want to add an operating temperature. In this case, I don't want that to just be a single analog value. I actually want to basically have not only the current value, but some units and perhaps eventually min-max ranges and whatnot. Since I haven't created sort of a temperature model before, we're going to do that inline. I'm going to create a model. I'm actually going to call this temperature. And I'm going to add a couple attributes. The first is going to be current value. And that's going to be a floating point value. And I'm going to give it some units. And that'll be a string. At this point, I'm going to actually commit this temperature model. What you'll notice, that model is now created, it's in our library, and we can reuse it as we define other models in the product. We've now basically modeled what we want to represent, how we want to represent any machine and on our particular line. And so at this point, I'm going to commit the actual machine model. As you can see, we can still go in here, actually see the submodels and manipulate them as needed. If I go back to our model library, we now have the asset information that I had configured previously before the webinar, as well as the new temperature model and the machine model that we actually just created. And I can tunnel in and actually see the submodels very easily as the library grows. So now what we want to do is we actually want to wire up and model a real world machine based on this blueprint. And that we call instances. Here I'm going to create an instance called machine X. And I'm going to select the model machine. At this point, we basically have, we're confined to what we actually define the model to have: the asset information, the online, the utilization attributes, and the operating temperature. This ensures standardization as we go and build out real world devices in our environment that we want to share with other applications. So for instance, the first thing we need to do is we need to create instance specific asset information to attach to this machine X. I'm going to do that by creating a new asset information. And this is going to basically bring up the actual submodel where I can apply an ID, a serial number, and a purchase date. As we've shown previously, this expression can be any JavaScript expression where we pull in multiple inputs and do math on them. For today's webinar, we're just going to use a single assignment to some of the inputs that we brought into the project. The default values allow us to put in metadata that either basically, when real-time data doesn't exist, or if we want a default value to basically show up in a particular model in the event that we cannot read from the underlying data source. So it actually provides two purposes. For simplicity, we're going to basically pull in some of those inputs that we browsed earlier: the asset ID, the serial number associated with the machine, and the date acquired. So the interesting thing here is you can see that at this particular site, they had their own naming convention for how they basically identified assets, provided a serial number, and actually the purchase date. We've standardized that, so regardless of site and what this underlying expression would actually hold, we basically can conform to this standard. Next, I'm going to basically add a couple other real-time data points: the online state of the actual machine, as well as the utilization rate, or what they called work in process at this site. Lastly, we're going to basically create the temperature value. In this case, I'm able to get the current value directly from the underlying data server, but there are no units. However, I know that I want to standardize all my temperatures across the board in degrees Fahrenheit. And so I'm actually going to enter that in as a default value to add that piece of metadata to the model. At this point, we've actually modeled machine X based on the model type that we've created called machine. I'm going to submit that. Now we're going to go back and we're actually going to go look at the actual instances. You'll notice a few instances are created. The machine X that we modeled, but we also have broken out some of the sub instances that we've had so that you can actually reuse those building blocks for other things of interest. For instance, you might want to create a model that basically represents a catalog of asset information for all your machines. You could do that and then just basically go in and pull in the machine X asset info as block, as well as asset info blocks for all the other machines in a particular site. The next area of capabilities that we've added to 1.1 is around flows. And flows are really what basically is the pipe between the raw data collection, the population of the models that we're creating, and how we actually go and publish those out to a particular application. And so I'm basically going to create a new flow called machine feed. And I'm basically going to source this. And though you can pick raw inputs, we're actually going to go find that machine X instance that we modeled. The next thing we're going to do is figure out where do we want to publish the actual results for the source. I'm actually going to leverage MQTT for this. So we're going to publish the results of the model to an MQTT broker. And I'm going to publish that to a topic called machine feed. The next thing is to basically determine at what point should we execute this flow and do some work. In version 1 of the product, the only way that a flow could execute was based on a cyclic interval. And so I could set an interval and then basically, essentially, today we call that always run at this interval. So in this case, every 1 second, basically execute the model, populate it, and push it out. That is the 1.0 behavior. One of the things that we added was we no longer force the user to think in terms of milliseconds. You can put in some durations here. We'll do the math for you. So a nice, easy capability to make your life easier. The other thing that's important here is we've added these condition-based modes. So instead of basically always every 1 second going off and populating the model, you can now do this based on condition. And the 3 conditions that we support are on change. So at some point, every 1 second here, we're going to evaluate an expression for a change. And if it changes, we will then populate the model and publish it out. Likewise, the other conditions are on true. So when an alert is raised, for instance, or while true. And so perhaps maybe you want to actually execute this particular flow whenever the machine is actually running. For simplicity, we're just going to use the always mode so that we can actually see how this model actually is represented when we share it with an application. Lastly, in version 1, we always basically published, every update regardless of data change. And so in this new update, we allow you to basically look at the model, and if at least one attribute has changed, then we will publish it. To do that, you would select only changes. For this webinar, I'm going to select all so that we can get a steady feed of information. And then lastly, you enable your flow so that we can actually go and start collecting the data and run through the process. I'm going to bring up a MQTT FX test client that basically is subscribed to that machine feed that we're now feeding. As you can see, The model that we've created, machine X, basically has a timestamp that's associated with the time that we actually collected the data to actually populate the model, which was every second based on how we set up the flow, as well as populate all the attributes, the asset information block, the online block, the utilization block, and the operating temperature block. And so that's how we represent complex information models to other applications. We also provide the actual types associated with the models so that somebody could actually do some mapping within their applications. But one of the benefits of the Intelligence Hub is that we can actually modify these on the fly, extend them. So let's assume we've built out a bunch of models and instances for machine A, B, all the way through Z. And we decide, you know what, we want to actually know the min and max range associated with an operating temperature. How do we do that without having to go and modify all of our machines? Well, in this case, I can actually go back to the Intelligence Hub configuration. I can bring up my model. I can actually go to my temperature, for which we're actually going to go and modify its actual model representation. We're going to add a min and a max. And we're going to actually commit that change. So now temperatures basically can have these 4 attributes. It's interesting. I purposely didn't select the required field because I didn't want to break my existing project. So for instance, if I bring back up that application, we're still publishing temperatures right now with just the 2 attributes, current value and units. Why? Because we actually haven't wired up the data points for the particular instance called machine X. So we'll do that now. I have basically the operating temperature. When I extend it, I now actually have these other fields that I can fill in. Well, because I don't have real-time data points that actually, respond to the min and max, I'm actually just going to basically put in that metadata right here. And for instance, let's assume for this particular machine, the minimum operating temperature really is not applicable. I just want to put in a max. I'm going to put in 80 degrees here. I'm going to basically, persist this update, and then I'm going to go back to our application and see that without making any changes to the client application, we're now basically modifying a model in one place and propagating that through the system. Again, this webinar shows a very simple example of a simple machine, but if you had hundreds of machines, you could do that in one place and propagate that through the entire system, making unique changes based on instances where needed. So that really concludes sort of the overview of the new features for the HighByte Intelligence Hub 1.1 release. I actually would like to open it up to questions. I believe I've seen quite a few questions come through as I've been talking. So I'm hoping, John, you've kind of collected those and can start feeding those.
Hey, Tony. Yeah, thanks. We have received a number of questions that have come up. So maybe we'll just start at the top. First question came up is about Sparkplug-B support for MQTT.
Yeah, that's a great question. So today we don't support Sparkplug-B, but it's actually on the roadmap for our next release. So our plans are to ship 1.2 in sort of the end of September timeframe, where we actually are going to support the Sparkplug-B specification. For those of you who aren't familiar, MQTT is a very generic interface for allowing us to go and publish data very rapidly to a piece of brokering technology that people can subscribe to and pull data out of. Sparkplug-B is sort of a bunch of is industry coming together to define what the layout of the data that gets pushed into the broker should actually look like, as well as some other things in terms of making sure that the actual edge-based devices like us are actually healthy. And so that's coming in our 1.2 release in the very near future.
Great. Tony, another question that came up is, do we have any benchmark data or any typical ranges of volumes of data that people can put through the system?
Yeah, that's a great question. So one of the things that we wanted to do when we actually designed this product was we wanted to be able to run on something as small as a Raspberry Pi. And so we actually have the Intelligence Hub, running on a Raspberry Pi with 10,000 data flows, building 10,000 models with various inputs and basically publishing an MQTT topics at a 1 second interval. So we're able to get quite a bit of throughput out in a small duration of time. We haven't gone by, past the 10,000 mark. That's just been in sort of a sweet spot that, we wanted to target. But, over time, we see ourselves being able to scale even larger than that. The one thing you can remember is that the way that we actually price the package too, you can install multiple instances of the hub so that you can actually sort of offload some of the work onto multiple machines to get even better throughput.
Tony, a question about nested models. How deep can they go? Are there any limits to that?
Yeah, we decided not to actually limit that. If the only limitation would be, system resources really, which we would catch, and we would basically let the user know that we just can't construct the model. But there is no limit in depth. We basically will ensure that you can't create recursive paths where, assume one model references another model, which kind of loops back to itself. So we make sure that those checks are in place, but we haven't actually put in any hard limits onto how far you can go. So you create something that basically has, as many depths as you want. And as long as you have enough, memory and resource to be able to go and basically construct and work with those models, there will be no issues.
Great. Another question. It looks like the modeling list was a flat list. Is there any way to organize that or to filter that down?
As far as the models, John?
Right.
Yeah,
to organize the models.
yeah.
So
that's a great question. So as you saw us pumping out models, you saw that this was a flat list. So again, one of the things that we're actually going to be adding in 1.2 is the ability for people to categorize these models after the fact, by tag them and be able to get different views into them so that you could easily see them all, or you could basically compress them. So for instance, even though we've added some submodels on your behalf, when we created these inline, when we created the machine X instance, we kind of show them here. You may want to just hide those because they may not be applicable. You may only care about the asset information and the operating temperature in the context of machine X. So we're going to provide the ability for you to go in and select how you want these things to be grouped and sort of hidden behind the scenes if they're things that you don't actually need direct access to. That'll be in the 1.2 release coming in September.
Great. Let's see here. So since we're looking at instances and I see all of the sub-instances get created or the instances of the submodels get created, can I also use those in a flow?
Absolutely. So when you come in here and you create a flow, we basically will show you all the inputs that you've brought in across all your data servers. And all the instances you've created. So for instance, I had mentioned earlier, if you wanted to go back and say, I have a particular application that just wants access to all my asset information, you could create an asset catalog model and then basically populate it with just asset information blocks from all your particular machines and then push those out. So yep, anything that you basically see here can be a source to a flow.
Great. Let me look through here. Is there any way to see which instances are related to a specific model?
Yeah, so if you go in here and you look at machine, for instance, and you look at details, we have a usage tab that actually shows what instances are actually being leveraged. And obviously this list will grow as you start modeling multiple machines, and obviously click into them so that you can actually tunnel in and actually do some modification on a machine by machine, or I should say in this case, for clarity, instance by instance basis.
Question came up here. Is the full namespace available for publishing? Or are we limited to creating a flow that publishes just a single model? Sounds like, can I publish multiple models in a flow? Or, yeah, if you want to take that.
Yeah, absolutely. So today, when I go look at the details, you basically you can clone flows and have multiple. So I could have multiple sources going to the same target. And so in that way, you could collect data from machine A, B, C, and so on, and publishing to a machine feed from in a single topic living on a broker. So we've actually set this up where in a future version, you'll be able to pick multiple sources or targets and do some multiplexing for a single flow. So rather than a one-to-one relationship between a source and a target, you can actually have a many-to-many relationship to make that even easier from a maintainability perspective. Today, you would do that by basically creating a new flow or cloning an existing and selecting the additional sources that you want to publish to that particular target.
Right. Or as you had said, as we went through the demo, you could create a secondary model that becomes a roll-up of submodels.
Exactly.
And then you could just flow out that secondary model. So
exactly.
Or that, I guess that would become a primary model, but yeah.
Yep.
Okay. Just looking through here. So a little bit about the logistics. Are there any prerequisites for installing the software and getting it up and running? And how can people try it out?
Yeah, so we do provide a couple. I mean, we have an installation guide that ships with the product. We also have done a couple videos to show how to install it on Microsoft Windows as well as Ubuntu Linux. There are a couple dependencies. So the runtime requires a Java runtime. In version 1.0 and 1.1 this release, that happens to be the Oracle specific Java runtime. And so that needs to be installed. We go through the instructions on how to do that, how to acquire it, how to install it, and set up the backend product. I will make note that in 1.2 coming in September, we're actually going to remove the requirement to be the Oracle Java runtime so that you can actually use OpenJDK, which is, in Linux anyway, it's already pre-installed. So it'll be one less step that you'll have to worry about. On the configuration side, what we've done is we basically have built the component such that you can host it in any web server. So it will be up to you to actually go and stand up a web server and basically plop the components into that to be able to go and serve up the configuration. Again, both installation videos show examples on how to do this on both Windows and Linux. For Windows, we actually show how to install IIS and actually drop the components in. For Linux, we actually just show how to use the out-of-the-box Python-based HTTP server to stand up a folder as a web server. In both cases, those videos are less than 5 minutes. So the amount of effort to go and stand these up with the required dependencies is a pretty small lift. We do plan to have a more official installation in the future, as well as the ability to go and provide a distribution that is very container friendly to make it even easier to stand things up as you go and deploy and scale out your enterprise.
Tony, a question here back into the product about that expression field, and you had shown it just referencing a specific data tag. Is there additional capabilities in that expression field?
Yes, absolutely. So if I go back here and I want to go and select, let's say, on true for a particular mode, this will basically enable this expression. This same expression field can be used as attributes to models as well. But I could actually search something that basically says, okay, if the utilization of this thing is less than, say, 50%, then I actually want to go off and run this flow, execute this flow, which could be sort of some kind of warning to a system that says, hey, something doesn't seem right. You probably need to, pay attention to what's going on. Again, this can be any number of inputs. And they can come from various data servers. In this case, it's just a single one where we're doing a comparison against the value of 50%. Any basic JavaScript, you can basically, leverage right here in the expression builder.
Great. Yeah, and there's a question around what our strategy is. There's been a lot of discussion with OPC-UA and companion specs and certain other applications that have their own modeling requirements. Do you want to comment on?
Yeah, yeah, absolutely. So we don't want to have just another way to model things that basically allows our, forces our customers to be able to go and just have one more thing they need to maintain. The goal here with the Intelligence Hub is to simplify, the creation and maintenance of models across all your applications. So what we have plans to do is to basically look at companion specs from like OPC UA and say, how do we take the models that's been defined and implemented in an underlying UA server, map them to our models so that we can transform them to another application that may not be OPC UA aware. What that really means also is it means that non-OPC UA aware application probably has its own way that it likes to consume models. We will do that transformation for you. That way you're not going into all your different applications whenever you need to do something as simple as add that new, max value attribute for a temperature. You could do it in one place and propagate it to all your applications automatically. Most applications that we're seeing in this space, have their own modeling mechanisms, but they also have third-party access to be able to go and, push models into them. So we see ourselves being able to simplify that scalability and maintainability of getting everything across the board in sync, if you will.
Yeah, that's great. To add another point to that, based on some of the conversations that I've had with a number of prospects recently, the OPC UA Foundation the OPC Foundation has identified these different groups which have defined a semantic layer, and then OPC has said, but use our server for the or use our protocol for the protocol layer. The challenge that many companies have is that they have a lot of equipment that doesn't know that semantic layer and was purchased far before these specs came out. And so we've all had a number of discussions with customers about we can model that semantic layer. In fact, I've modeled up, for instance, a machine tool from the MT Connect semantic layer right within the Intelligence Hub, which allows you to apply data coming off that machine tool into that semantic definition that MT Connect defined, and then move the data on over MQTT. So this essentially can help you apply those models to your existing equipment that maybe doesn't support them already. So there's a lot of discussions there around how do we apply that. I guess the last question that I'm going to throw at you is people are asking how they can try it out. What are the next steps here?
Yeah, well, I mean, that's really sort of what we're hoping. We want everybody on the call to engage with us, to learn about what we're doing, where we're taking the platform, as well as provide feedback into that process. But more importantly, the only way to be able to successfully do that is to get access to the product. And so, I'd say, you're more than welcome to reach out to both myself and John. If you go to the HighByte website, there is actually a link to how you actually request trial access as well. Ultimately, it'll get to one of us, and we'll be able to get you access to the product, as well as help answer any questions to make sure that you can successfully evaluate the product.
Great. Well, I just want to thank everyone as well for joining us. I know it's the middle of the summer for most, could be the dead of the winter for a few, but we appreciate all of your time. We appreciate your engagement, and we'd love to talk with you following this session. So thank you.
Yeah, thank you. Appreciate everybody joining today, and look forward to hearing from you in follow-up conversations.
Great.